All right, guys, welcome back. So before we start the actual implementation of the k nearest neighbor, what I'm going to show you the equation or the mathematical model, just to revise the concepts, so you can easily understand once we go into the dev environment. So you can see the equation. This equation is very simple. Like I mentioned the last time, that we are going to calculate the distance between these 2 points using the Pythagoras theorem, and that is obviously the sum of the difference between each dimension of one point from the other, right? So it is more like, you can see this solid line. It is representing the diagonal, and how we're going to actually calculate the length of this diagonal, or the distance between P and Q. We're going to actually subtract the square of Q1 minus P1 from the sum it up with the Q2 minus P2 square, right? And obviously, if you want to calculate the distance, because the equation is coming in square, so we're going to actually take the square root on both sides, and that will give us the distance between these 2 points, right? So based on that distance, we can find out the nearest point to my point which I'm interested in, and then whatever points are close, they are going to call nearest neighbors, and whatever attributes I'm going to see there, those attributes I can use. Or for example, if we are talking about book, if those neighbors, they have some books that this user hasn't actually read, I'm going to actually recommend those books to this user, right? A very simple implementation and easy to understand. All right, so let me come into my dev environment just to show you another side of the k nearest neighbor from another diagram. So if you can look into this picture, so for example, that is my point, right? So these are all the other points in that space. So you can see, I can clearly see these 4 points. For example, if I'm actually calculating the nearest neighbor, so these 3 points, they are closer to my subject point compared to other points, right? So these three are the closest neighbor to my point, right? So whatever books these three users they are reading in common. So if, for example, I have one book which is common between the three, so that means I can actually recommend that book. And if that book was not read by this green user, which is the point of interest for us, so I can recommend that book to this user, because that book is common between these 3 points, right? And I believe, or the machine believe, that that book might interest, because these 3 points, they have a similar interest, or they are closer to this user compared to other user, right? So that's the whole concept we are going to apply. Now imagine we are just using all the data, we are not applying any logic, because that's the database logic that we are going to use, right? So that's the biggest difference between coding anything through the business logic, because that's going to be static, or building the logic based on the data, right? So our recommendation is going to be based on 3 point. Yes, tomorrow, if we have 2 more points which are closer to these three, then obviously the recommendation will change automatically, right? We don't need to code another logic rule to address those new points. So that's the whole efficiency and intelligence of implementing these machine learning algorithm. Now, so we are pretty clear on the equation, and we are pretty clear on the internal mechanics by this diagram. Now we are jumping into our logic that we are going to build. So I just pick up a random user, and you can see this guy is I have the user ID. And these are the 4 parameters I'm actually passing to my machine learning algorithm. By the way, you can convert it into the store procedure and you can automate it. You don't need to run it manually. We can literally automate that recommendation store procedure every, every hour, or it really depends upon the frequency. Obviously, if we are keeping the data from our website and we want to literally keep it live, so obviously, whenever we know that the user is coming and he is visiting or she is visiting, we can run this algorithm and we can, do the recommendation. So that is on demand, or sometimes we just need to put the recommended item on our website as a general interest, that okay, these are the recommended item based on the collective interest shown by different user on our website. All right, so that's a quick introduction to the routine that we are going to do. All right, so let me first explain the parameters, and in the next video we're going to actually see the implementation, right? So we are obviously passing the user ID, which we are interested that okay, we want to recommend the books to this user, and then I'm passing the value of k, because if you remember, we are using the k nearest neighbor. So k nearest neighbor, like this neighbor, so if I pass the 10, so that means it's going to actually consider 10 points. So like in this example, we are only considering 3 points, but if I'm passing the 10, so that means I'm going to actually use the 10 points to find out the common book which I can recommend this user based on the k nearest neighbor score. And then obviously I'm customizing it more, that okay, how many recommendation I need to recommend. So in this instance, I'm just actually passing 5. And if you remember, once you go to any website, especially the shopping website on Amazon or Google or eBay, you can see you have the recommendation on the side or on the bottom, and there are number of items that you can see they have recommended based on your history, or based on your interest, or in some time based on your click, they also recommend you the product. So you can see that how the internal mechanics was working on those websites. Obviously, they have more data and they have different algorithm, but I'm actually showing this algorithm from the general perspective, that even small to medium organization, they can implement it and they can gain the benefits of the machine learning algorithm and get the intelligence into their system. All right, and then obviously we are not going to overfit our model or underfit our model. I've already discussed the overfitting and underfitting. So we are going to use the total instance and we can provide how many records we need to use to generate that recommendation. And then obviously it's not going to be one iteration. We can even run it multiple times to improve the recommendation. It really depends upon how our recommendation is working, whether the user is selecting or clicking. If not, then we keep refining, right? So that parameter is used for that purpose. But I'm not using in this one. I'm using my full data set because it's just 200,000 records, right? All right, so that's pretty much it from the parameter perspective. In the next one, we're gonna start discussing the internal mechanics of our recommendation system using k nearest neighbor. Stay tuned. Thanks for watching.